In section 4.1, we talked about different bases where we had some fixed number of symbols or digits that we could work with, but we could still count as high as we wanted to by using a positional number system. What if instead we looked at a number system where there were really only finitely many total numbers to work with? This might seem like a silly question, but we're actually used to dealing with this sort of a number system already. For example, when we look at time is measured in the same kind of a way, right? The only real times that you can have are somewhere between 1 o'clock and 12 o'clock, and then it restarts counting at 1 again, unless you're working in military time, but we'll put that aside and only work with numbers or with times 1 through 12. Now, for example, if it's currently 10:30, then what time will it be in 3 hours? It's not as simple as just adding 3 to the time here, right? If we just tried to add 3, we'd get 13:30, but 13 isn't really a time that we work with. And so we know that actually in 3 hours it's going to be 11:30, 12:30, 1:30, right? It'll actually be 1:30, right? So what happens is once we hit 12, we restart again, right? So similarly, if it's currently 10:30, what time will it be, how about in 9 hours? Well, again, you could try to count in your head if you wanted to, so 11:30, 12:30, and then we restart again, and we have 7 more hours to go. 1, 2, 3, 4, 5, 6, 7. So it'd be 7:30 in 9 hours. What time will it be in 12 hours? Well, this one we don't really have to count in our head to figure this out, because we know that 12 hours from now, we're going to be right back around to 10:30. So the key here to notice is that when we're working with time, right, or when we're measuring in hours, adding 12 hours is equivalent to adding 0 hours, right? If we were to add 24 hours, that is also going to be like adding 0 hours. Any multiple of 12 really is effectively going to act like a 0 when we're working with measuring time in hours, right? In the same way, adding 15 hours, if we wanted to know what time it's going to be in 15 hours, well, adding 15 hours is like adding 12 hours and then adding another 3 hours. And we just said that adding 12 hours is equivalent to adding 0 hours. And so in a sense, 15 hours, adding 15 hours is equivalent to adding 3 hours. Either way, you're still going to end up at 1:30. If you start at 10:30 and you add 3 hours, or if you start at 10:30 and you add 15 hours. So essentially, what this means is that 15 and 3 in some sense are equivalent when we're working with time. We can express this idea with the following notation. We say that we measure time with a modulus of 12, meaning 12 is going to act as a 0. And so in this sense, we have that 15 is equivalent or congruent to 3 mod 12. That's how we would express this idea here. Adding 15 hours is equivalent to adding 3 hours, or what it means is that in a number system where 12 is equivalent to 0, that would mean that 15 is equivalent to 3. In general, the expression x mod n refers to the remainder when we divide that number x by n. So up here, 15 mod n, or 15 mod 12, is going to refer to the remainder when we divide 15 by 12. I should say this represents the remainder of 15 divided by 12. And if you did your long division out, you would have, all right, 12 goes into 15 one time with a remainder of 3. That's why we can say that 15 is congruent to 3 mod 12. And in general, if a and b have the same remainder when divided by n, we would write a is congruent to b mod n. So this n here, in our examples that we've done so far, has always been 12, because that's the example that we're familiar with working with. But in general, you can talk about modular arithmetic using different moduluses, or moduli maybe, right? Changing this to a different number, and we'll see some examples of when you might want to do that and what contexts. So let's look at a few examples just to make sure we understand how this works. So we've seen already that 15 is congruent to 3 mod 12, and 13 is going to be congruent to 1 mod 12. Why is that? Well, if we divide 13 by 12, we get a remainder of 1. Another way of saying that is you can express 13 as 12 plus 1, right? 1 copy of 12 plus 1. That remainder is what it's going to be equivalent to mod 12. Similarly, 14 is going to be equivalent to 2 mod 12, because when we divide 14 by 12, we get a remainder of 2. Another way of saying that is we can express 14 as 12 plus 2. All right, what about 19? We're skipping ahead a little. I don't like the division way. You can continue to do this if you want, 19 divided by 12, and see what the remainder is. But remember, you can also try and express it as a multiple of 12 plus some remainder. So 19 is just 12 plus 7. So 19 is going to be equivalent to 7 mod 12. 24, well, what's the remainder when you divide 24 by 12? 24 is a multiple of 12, so there is no remainder. So this should be equivalent to 0. And that makes sense, right? Adding 24 hours to your current time is going to bring you right back to whatever time you were originally at, because 12x is a 0, so it's like adding 0 twice, right? 24 is equal to 12 plus 12, plus nothing, no remainder. All right, what about 29? Well, let's try to express 29 as a sum of 12s. Well, we've got 12 plus another 12, that gets us up to 24. Then we would need 5 more to get us up to 29. So 29 is equivalent to 5 mod 12. Now let's jump all the way up to 76. All right, now just like before, you could use division here. You could divide 76 by 12 and see what the remainder is. Or you could try to express 76 as some copies of 12. So how many copies of 12 is going to get us close to 76? Well, 12 times 2 is 24, 12 times 3 is 36. I think the closest we're going to get is 72, which is 12 times 6. Right, 12 plus 12 plus 12 plus 12 plus 12 plus 12. That gets us up to 76. I'm sorry, 72. We need to get up to 76 though, so we would need an additional 4, which means 76 is going to be equivalent to 4 mod 12. All right, so hopefully we see how this works in the example of looking at sort of clock arithmetic, like working with time. But in general, we can use the ideas of modular arithmetic in other contexts as well. So let's look at another example. It's a little bit different. If today is Sunday, what day of the week will it be 7 days from now? Okay, this seems simple enough, right? Every 7 days, the calendar of the week repeats itself. So 7 days from now, we're going to be back to Sunday. What day of the week will it be 9 days from now? Well, let's start with the fact that we know that 7 days from now, we're going to be back to Sunday. 9 days from now is just 7 plus 2. So adding 7 gets me to Sunday, and then that extra 2 days is going to get me to Tuesday. 25 days from now, let's try to use that same idea. 7 days will get us back to Sunday, another 7 days back to Sunday, another 7 days back to Sunday. So 21 days have gone by so far. We need an additional 4 days to get 25, which means instead of actually counting 25 days into the future, I know that in 21 days we'll be back to Sunday. So I just need to add 4 days to that. So from Sunday, 4 days from that would be Monday, Tuesday, Wednesday, Thursday. And finally, what about 80 days from now? All right, let's try to use the same idea here. We add a whole bunch of copies of 7, until we get close to 80. The closest we can get without going over would be 77. So if we have 11 copies of 7, that gets us up to 77, and then an additional 3 days will get us to 80. All right, so from Sunday, an extra 3 days would get us to Monday, Tuesday, Wednesday. So when we're looking at days of the week, it's now going to be 7 that acts as a 0. Seven acts like a 0 when looking at days of the week. Because every time we add 7 days, we reset. We get back to our original days. All right, which means 7 is equivalent to, or congruent to 0 mod 7. And based on our work that we did up here, we can see that 9 is congruent to 2 mod 7. That 25 is congruent to 4 mod 7. And that 80 is congruent to 3 mod 7. Right? So let's do an exercise here. I'm gonna pause this video, have an extra video, we'll go through this in a second, but you should take a minute to try this yourself. Fill out the following table and determine what each number is congruent to mod 4. So now we're working in a world where 4 is equivalent to 0. So every time you add 4, it's like adding 0 and it resets again. So I'll get you started here. 0 is just equivalent to 0, 1 is equivalent to 0, 1 is equivalent to 1, 2 is equivalent to 2, 3 is equivalent to 3, but 4 is equivalent to 0. Now 5 we can express as 4 plus 1, and remember that 4 is equivalent to 0, so 5 would be equivalent to 1. So why don't you go ahead and fill out this table. And then, once you filled it out, maybe think about what would happen if you tried to go the other way. If we tried to extend this to the negative direction.